Hi everyone, welcome back to our YouTube channel, Becoming a ROS Developer. So today we've got Jose, who's doing a ROS 2 presentation on a real robot. He has just completed the course ROS 2 Basics with Python. So as usual, we'll first begin by seeing the demonstration on the real robot, and then we'll get into the details about how he managed to do his project, and then later on we'll get to ask him a couple of questions. So I'll now hand over the platform to him so he can begin his presentation. Alright, Jose, whenever you're ready.
Oh, yep. Just waiting about
Alright,
30 seconds. It should connect.
sure.
Yep. Alrighty. Move the robot there.
Alright.
Okay. Alrighty. I'm just gonna move the robot to a good starting point. Let's just go to the white checkered line.
Mm-hmm.
Okay. Up. Up. Come on. Doesn't seem to be uh there appears to be some latency, but that
Yeah,
should be
so
fine.
I just wait for it a little bit.
Um,
I see the laser scanner is still spinning. Okay.
About a second. What if I...
Yeah, still.
Okay, that's fine.
Alright, let's give it
I'll just
a
try it
bit of
anyway.
time and see.
Okay. But first, what we always do is we go to the ROS2 workspace. Then we will build the packages that we made for this project, our custom interface, and our wall. All right. Then we
Mm-hmm.
source install slash setup dot bash. And now we launch the program. Wall. Main dot launch dot I.
Mm-hmm.
Hope I should probably make this bigger. All right. So right now it's looking for the wall.
Alright.
Yep. It keeps rotating right. Oh, it's found the wall. It's moving
Okay.
closer.
Okay.
Now it's rotating itself to the left to align itself with the wall. It's looking for that perfect laser. Oh, it's found it.
Mm-hmm.
Yep. Now it's avoiding the corner while still maintaining the set distance of 0.2 meters and 0.3 meters.
Okay.
Veering a little bit off, and it corrects itself using the controller. Up, it's detecting. It should turn.
Mm-hmm.
Hmm. That's odd. It shouldn't. It worked the last time.
Mm,
The
maybe
code
try
hasn't changed.
from a different location and let's see.
Perhaps, perhaps. Alrighty. And doesn't appear to be responding.
Mm. Did you terminate your program?
Yes.
Okay. Then maybe try running it again from there and let's see if it can rotate to try to find the wall again. If it isn't stuck in the corner. Okay, it's spinning a little, but okay, there we go.
Hmm. I think it's too close to the wall.
Yeah.
Should be backing up. I don't know why.
Try tele off once more.
Hmm. Doesn't appear to be moving. Trying to control it.
Um,
Hmm.
can you try sending commands in the command line? Send maybe commands to go back.
Hmm. Uh, maybe let me disconnect and reconnect to it.
All right.
That's odd. It worked last time. The code hasn't changed.
Yeah, and uncertainties of the real world, right?
Hmm. Uh, oh boy. Okay.
Reconnecting. Okay. Okay, there we go.
Okay, there we go. Yeah, there we go. About right there.
All
Alrighty.
right. And
Now, I'll just do the same thing. Mouse to worksheet.
you've already built. Do you want to reboot again?
Yeah, I have to,
All right.
since I, sorry about this.
It's all right. It's all right. We would like to see it
Source.
work, so wait patiently.
Okay. Oh, okay. Mm-hmm. Sometimes this happens. It's looking for the
Perfect.
perfect one
Yeah.
to face. Yeah, that exact laser point to hit the wall as it's turning.
Right.
Now it rotates itself to the right side. Yep. Yep. There we go. That's what it should be doing in the corner. Oh, a little bit off. As you can see in the web show, we're getting closer to our starting. There we go.
Right, right.
All right, let's see. It hopefully if it gets to 5 centimeters or less from the starting point, it should stop.
Yeah.
Okay. I don't know why I guess it's that corner it doesn't like. 0.4, 0.3, 0.2. If we can get there, 0.1. And
Oops.
it
No, it's
didn't reach it.
increasing. Yeah.
Okay.
Okay. All right. Yeah, you could stop it.
Well,
And
but it completed the lab.
yeah, that's good.
Yep.
So let's get into your presentation now.
Okay. Alrighty. So, hi everyone, this is the ROS2 Basics in 5 days with Python.
Mm-hmm.
I'm just a little bit about me real quick. I'm Josue Valladares Jr. I'm a senior electrical engineer at the University of Houston. And just a quick interesting fact is that I raise chickens and my family owns a restaurant for the past 30 years. So the goal for this ROS check is to, one, locate the nearest wall
Mm-hmm.
and have the robot find that wall. And once it finds it, rotate to the left so that the right side and the wall are, I guess you'd say, adjacent or parallel.
All right.
And once that happens, then we initiate, I'm sorry, then we follow the wall along a lap, as you saw a few moments ago,
Yes.
main, making sure that we turn left in the corners and avoid what happened the first time. But while this is happening, we're tracking the total distance we've traveled and returning a list of odometries that we've recorded. And what was supposed to happen was that if we had gotten less than 5 centimeters from the starting point, our first odom, if you saw,
Mm-hmm.
it would stop and return the total list of XY points that were stored in our array.
Right.
But a quick overview of the robot and differences between that and the simulation. For the simulation, the robot had about 360 data points with an angular range of 0 to 2 pi or 0 to 360 degrees. The front of the robot was indexed at 0, while the right side was 270. As for the rear robot, this one had a total of 720 data points. Its angular range from negative 180 degrees to 180 degrees. And the front of the robot was indexed at 360, while the right side was 180. So a quick setup of our wall finder, which the project asks us to, as you saw, main.launch.py, it asks us to put the programs in an order,
Mm-hmm.
first with wall finder, then with odometry, and then with wall following. So that's how I organize them. So the wall finder service will locate the wall. If it's not on this side, then it will turn to the left. If it's not on the other side, it will turn to the right.
Mm-hmm.
And when it has indexed it, which is what you saw, it had to find exactly when the front of the robot was facing the wall while it was turning back and forth, which is why it took a while. Once it happens, it will check if we're greater than or less than 0.3 meters away from the wall. If we're farther, then we'll move forward until we are. If not, then we'll begin turning to the left so that the right side is facing the wall.
Mm-hmm.
For the wall finder, we used topics and services. For our topics, we used a publisher and a subscriber. We publish to cmd_vel so that we can send velocity commands to it, and we subscribe to the laser scan so that we can receive the data from the laser points from the real robot.
Mm-hmm.
As for our services, we create a service server for the custom interface find wall to ensure that the Boolean response value is true.
Mm-hmm.
As for our code setup, the next step is odometry. So the odometry callback gets the first odometry value, as you saw in the beginning, if it was for a brief moment, but it said first odom recorded. And then as we're moving, we update our current position and how we calculate our distance to the original point is with the Euclidean distance formula in 2D.
Okay.
And right here at the bottom, or sorry, right here at the bottom, we were supposed to get less than 5 centimeters from it.
Okay.
And if we had, it would have broken off and sent the recorded data points.
All
Sadly, that
right.
did not happen this time. For our topics and actions, our topics, we have a subscriber to the odometry so that we can receive our estimated position over time, which
Mm-hmm.
is pretty standard, what you'll learn if you take the course basics. Our actions, we have an action server to record odom, which provides other nodes such as the wall following robot to call upon the action functionality.
All right. All right.
And finally, our wall following behavior, it will call the custom service find wall to align with the wall. And then it will begin recording odometry, sending a goal to the custom action server to record its odometry. And while this is happening, we'll implement wall following control. And as you saw, if it got too close to the wall, it would turn left. If it got too far away from the wall, it would turn right to get closer, and back and forth to get our ideal distance of between 0.2 meters and 0.3 meters. For the wall following, we had to use topics, services, and actions, all of
Mm-hmm.
them. As usual, we had to publish 2 CMD-val to send linear and angular velocities.
Mm-hmm.
We had to subscribe to laser scan to receive the data points. We had to use a service client because we made a service server in FindWall. And for our action client, we had to connect to the action server in odometry, odomrecord.py.
All right.
Yep. And that brings us to the end of the presentation.
All right. All right. Very nice presentation, I would say. Um, I've got some questions for you. So, first of all, um,
Mhm.
I would like you to take me through the process of how your odometry update is done, right? So you mentioned something along the lines that it gets updated as the robot goes, right? Can you take me through
Yeah,
that code section where that is done?
let me just open it up right here.
All right.
Okay. Alrighty. So right here we have our reaction call group.
Mm-hmm.
We create our action server and we subscribe to the odometry.
Mm-hmm.
Here we make our last odom a variable of 0.32.
Mm-hmm.
This is just to initialize it. We have our odom record, which is our array, which is just blank, our first odom, our total distance, and our last x and last y value are all none, just to initialize.
Okay.
Our odometry callback will, oh, sorry, will get our positions, such as this. I realize now that I didn't need z,
Okay.
so this can just be ignored.
Because it's always zero, right?
Hmm? I'm sorry, say that one more time.
Because it's always zero, right?
Yeah,
It doesn't
basically.
change. Yeah.
No. And then right here, if it is none, then we update it. Oh my God, sorry. We update it, record it, first odom recorded,
Okay.
which is right here,
All right.
and then we set the last as those values. As for our action callback, right here, we just have a self logger which just tracks it and it tells us that it's happened. We're executing our odom recording goal.
Mm-hmm.
And here we have our feedback message,
Okay.
which is standard with actions.
So the callback is responsible for giving feedback in this case, right? This action callback. It's responsible
Pretty
for
much.
giving.
Yeah.
Okay, I see. I see. All right. Okay, I'm pretty happy with that one.
Okay.
The other question I wanted to ask you is, so you noticed that your robot didn't stop at the very beginning, right? Or when it passed there where it started. how could you have made it stop,
Yes.
right? Okay, do you have anything off the top of your mind?
How to make it stop
Yeah, how
at
could
the
you have
at the
changed
origin,
it
or just like how to make it stop
after it has
at that
completed the
point
loop? Yes.
after it's completed the loop?
Mm-hmm.
Well, hmm, I guess I would say after a set after a certain distance traveled, I could make it stop like that, or to ensure that it actually reaches where it started, we could do a sort of return to origin like we did in the basics. I believe it was for topics or services. But essentially, what I would do is to return to the origin point or the starting point as close as possible.
Mm-hmm.
The robot has to perform corner avoidance 4 times. Go this way, this way, this way, this way. Inside that loop, I would make a counter, and when that counter reaches 4,
Mm-hmm.
I would initiate a sort of return to origin function
All right,
that
that's
would
it's a very interesting way of thinking about it. But
yeah,
yeah, what maybe you could have just increased the distance that it checks, right? So you notice that it
that's true.
was, yeah, 0.05. If it made it point 0.1,
Yeah,
so whether it misses it by a couple of centimeters or so, it will still notice that I'm within the point 0.1 range, right? So most of the time
that's
it
true.
stops when you use that number. So I just that's where I was trying to get you to, because you have to think
Well,
about the point of the beginning in a radial form, right? So sometimes you miss the
mhm.
center, but you also want to know that you're within a certain range. So this one was quite tight, but it's fine. It's fine. It's
Yes.
just for the thought
I just
process, right?
I just did it because that's what it asked us to.
Yeah, it's good. It's
That's
good. It's good.
but yeah, putting it to point 0.1 or 0.15, that would stop it.
Yeah, yeah. The thought process is what I was trying to get you to. So the last question I wanted to ask you is, oh, again, why did you choose to use a service for your wall finder, right? Can you explain the theoretical basis behind that?
So the reason we use a service server in section 2 for the wall finder
Mm-hmm.
is that a service only sends information when we call it. We
Right.
use the service because it fits the nature of the task. We find a wall, align with it.
Mm-hmm.
That's a clear request
Right.
that
Right.
we're sending, and get a response back. We wouldn't use an action because we don't want feedback.
All
We just
right.
want to know if we found the wall or not.
Okay. All right. So to start your action, you want to know that if you found it, is it a true or false kind of
Yes,
return for? Okay, I see. All right.
which
Oh.
is yeah. Which if I go to the custom interface package,
Mm-hmm.
yep, right here we have a Boolean value of is the wall found,
All
true or
right.
false.
All right. I see.
Yep.
All right, Jose. Very nice presentation. Well done. Well explained also the details and some of the things that would have made your robot stop when you wanted it to stop. So that's quite good. All right, so we'll just do a wrap up and then we'll finish our conversation on Zoom. All right, so just hang on.
All right. Well,
All right, everyone. So this was Jose's presentation. To all those who want to give a try to the courses that we offer certification on, we highly recommend you give it a try. It will definitely aid in your ROS learning path. So until next time, keep pushing your ROS learning. Bye bye.